All right, we're looking at 11.2 notes today on theoretical and experimental probability. Now, we had done some experiments with this already. Probability is the measure of how likely an event is to occur. So probability is figuring out how likely an event is to occur. The result of probability experiment or situation is called an outcome. So when we're flipping a coin and I say I would like to see it be on tails, the outcome we want is tails. What are all of the things that could happen? All of the outcomes are heads or tails, and we want the heads to be on top. All right, the set of all possible outcomes is considered the sample space. So heads or tails would be my sample space. If I was rolling a die, what would be my sample space? 1 through, yeah, and I should say if I was rolling a standard die, it'd be 1, 2, 3, 4, 5, or 6. That's my sample space. Okay, event is what we want to happen. So we have possible outcomes that we can have. We have an outcome that we want. That would be considered the event. All right. So if outcomes have the same chance of occurring, those are equally likely outcomes. Long way of saying it. Equally likely outcomes. Now, if you think about this idea of equally likely outcomes, if I roll a die, a fair die, standard fair die, getting a 1, a 2, a 3, a 4, 5, a 6, aren't those all equally likely outcomes? Yeah. And when I say a fair die, that means it's not weighted, so everything has the same chance. Okay. Favorable outcomes are what you want to happen. What is favorable? Outcomes in a specified event. Now, the ratio of the number of favorable outcomes to the total number of outcomes is called theoretical probability. So theoretically is what should happen. Okay? So if we roll a die 6 times, are we guaranteed to get a 1 once and a 2 once and a 3 once? In theory, it should be a 1 out of 6 chances of getting a 1 and a 1 out of 6 chances of getting a 2. But is that going to happen if we do an experiment? Probably not. So theoretical probability is what should happen. And our experiment, the more we do the experiment, the closer we'll get to theoretical probability. Now, if you see this P with parentheses E, that's the probability of an event. So if I wanted to roll a 1, that'd be P of 1. I'm saying what's the probability of getting a 1, and then we get the probability. So P of E is equal to the number of favorable outcomes over the number of total outcomes. So number of favorable outcomes over number of total outcomes. Wow. All right. So we have a CD with upbeat dance songs and 5 upbeat dance songs and 7 slow ballads. What's the probability that we randomly select a song that is upbeat? Okay, how many total songs are there for them to select?
12.
Okay, total songs would be 12, right?
Yeah.
5 plus 7, 12 total songs. So I'm looking for the probability of, I'm going to do U for upbeat. The probability of an upbeat song, well, there were 5. That's my favorable outcome out of how many total songs? I thought it was 12.
Wow.
Okay. Now, it doesn't specify, so I'm fine with the answer of 5/12 as long as it's a reduced fraction, or we would round it, and what would the decimal be? Nearest hundredth. 0.4 what? Just take 5 divided by 12. Nearest hundredth. At 0.4, what's the next number?
0.5.
Show me your calculator. 0.42? Okay. So 5/12 or 0.42. Remember, probability is a number between 0 and 1. 0 means it's never going to happen, and 1 means it's 100% going to happen. So this is a little bit less than 50% chance. All right. A red number cube and a blue number cube are rolled. So if I'm referencing a number cube in this class, it's going to be a 6-sided die that is fair. If all numbers are equally likely, what is the probability the sum is 10? Okay, picture die. How many ways can I get a sum of 10? What's sum mean? Okay, so I can get a 6 and a 4 or a 4 and a 6.
2 and 8, 5 and 5.
Wait, hold on. So 2 and 8 or?
Wait, you can't get an 8.
8 and 2. Oh, you can't get an 8. You're right.
You fucking crank.
All right, so what else? 5 and 5.
5 and 5.
You guys are mean.
What's the probability of the sun disappearing? Or the world coming to an end?
All right, hey. Now here's the deal. There are 3 favorable outcomes. So the probability that we get a sum of 10, that P is standing for probability we get a sum of 10, it's going to be 3 out of what? How many different things can happen when we roll 2 die?
12. Wait, fudge, no.
It's not 12. Okay, each die has 6 outcomes, right? So that's where we're getting 12 because you're like 6 and 6. But it's not. What did we learn the last couple days? How many outcomes are there? Okay, so picture rolling the first die. And then we put how many things can happen when I roll the first die, the red cube? 6 outcomes when I roll the red cube. Agreed?
Yeah.
How many outcomes are there when I roll the blue cube?
6.
And what do you do with all possible outcomes?
Multiply.
You do multiply. That was that fundamental counting principle. So how many possible outcomes are there?
36.
So you need to slow down and think differently. A lot of us want to say 12. We were like 6 things and 6 things. 6 outcomes times 6 outcomes gives us 36.
How do you get 6 outcomes times 6 outcomes?
It goes down to 1/12 though.
Because
To help you make sense of this, here is a visual. You have 6 things that can happen on one die. I know they're not the same colors. And 6 things that can happen here. So 6 times 6 would give me 36 outcomes. So here's doubles. Now, anytime you do doubles, it only counts one time. Do you see how the doubles are on the diagonal? So you guys, we needed a sum of 10. Check out this chart. This gives you the sum. A 3 and a 2, or a 1 and a 2. See how the sums are? So there's only 3 ways to get a 10, and you name them. A 6 and a 4, a 4 and a 6, and then the double 5s. Okay? So be really careful. We had to take the total possible outcomes times the total possible outcomes. All right, now, I heard that this reduces. So 3 over 36 has to be reduced to what? 1/12? And what would be that decimal?
that'd be, I don't know.
Well, take 1 divided by 12.
0.0.
I believe it's 0.0. All right, 0.083 repeating, so we could say 0.08. So if you think about it as a percent, it's 8.3%. It's not very likely. All right, a red number cube and a blue number cube are rolled. If all numbers are equally likely, what is the probability that the difference is 6? What does difference mean?
Subtraction.
Okay, so let's start with this. We want the probability of a difference of 6. Well, I know how many outcomes there are when I roll 2 die. It is 36. Now, how many ways can I get a difference of 6? Guys, what's the highest number on my die?
6.
And what are my other numbers?
36.
Guys, I can get double 6s. The difference there is 0. 6 minus 6. 6 minus 5. Guys, 6 and 1 would be a difference of 5.
I thought that's what we want.
Can you do it?
It's 0.
It is a probability of 0. It is impossible. You will never find a difference of 6 because the highest number is 6, the smallest number is 1. Okay, so 0 means it's impossible. It's never going to happen. Okay, now, this one's a little bit different. The sum of all probabilities in the sample space is 1. So if we look at all the things that could happen, the probability is 1. right? That means if I roll a die, there's a 100% chance that I will get a number. Now, the complement of something is the opposite, what's left over. So in the sample space, if I say, what's the probability that I don't get this? I can either figure out the probability that I don't get it, or the probability that it's not the event we want. We would just do 1 minus the probability that it is the event we get. So instead of finding the probability of it not happening, I can just find the probability that it does happen and then subtract it. And sometimes that's easier if it's compound. Okay, so example 2. Go ahead and read this. 2 integers from 1 to 10 are randomly selected. The same number may be chosen twice. That's what's going to be tricky. What is the probability that both numbers are less than 9? Okay, this is not an easy one. We have to think differently. So 2 numbers 1 through 10. So 1 and 10 are included. They're randomly selected. The same number can be chosen twice. What is the probability both numbers are less than 9? Well, guys, how many numbers are less than 9 just in general?
9, 8.
It's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers less than 9. The only thing that I don't want is a 9 or a what? 10. And the idea the numbers can be chosen twice. So rather than figuring out what we don't want, or what we do want is all these probabilities, let's think about what we don't want. We don't want a 9 and we don't want a what? 10. So how many chances are that I get a 9? Or a 10? 2 chances out of 10, right? A 9 or a 10. So it's 2 chances out of 10, and then another 2 chances out of 10. Those are the ways I can do it. Now I can pick the same card twice. So the idea here is I could find this probability and then take 1 minus that. Now I'm going to skip the rest of this because it actually gets a little too complex because we have to consider the idea that the number can be chosen twice, and that makes it a little bit harder. But I think this next one we can do. So each student received a 4-digit code to use library computers. No digits repeated. Are we clear? So he received a code 7654. What's the probability that he would receive a code of consecutive numbers? Do you see how 7654 is right in order there?
Yeah.
So what's the probability that you can choose something with consecutive numbers? So when you look at this, this is considered consecutive numbers. Guys, this is not an easy problem. This is a little bit higher level. We want a 4-digit code. First of all, how many different codes are there that we could use? It says the numbers can't be repeated. How many digits are there when we're picking digits? 0 through 9, right? So there's 10 digits. Now, how many digits are we picking?
9.
How many digits are we picking? We want a 4-digit.
Oh, 4.
We want a 4-digit code, right?
Right.
Okay. So this would be a permutation because doesn't the order matter? So if I want to know how many possible codes there are, how many, you got to count 0. How many 4-digit codes are possible? You would do 10P4. Because the order of your code matters, we have 10 numbers, we're picking 4. So please type that in the calculator. What is 10P4? Yep. And this is how we type it in our calculator. We put in the 10. We go to our probability key. Some are up here, some are a little bit lower, but it's PRB. We select permutation because the order matters, and we're picking 4. Do you guys get 5,040? That's how many possible codes there are. Now, so we have this total. Now we need to know the probability. Guys, honestly, to me, the easiest way to do it was I listed them. What's the smallest number we start with? 0, 1, 2, 3. There's 4 consecutive numbers. Then rotate it out. What would be next? 1, 2, 3, 4. What would be next? 2, 3, 4, 5. Then 3, 4, 5, 6. 4. Do you see what I'm doing? I'm literally going through and listing. Then I would start with 5, 6, 7, 8, 6, 7, 8, 9, and that's where I'm going to stop, right? They have to be consecutive. Now, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7. Now, what about the reverse of them? Hey, I have 7 available codes that are consecutive, but if I reverse it, wouldn't 3, 2, 1, 0 be a consecutive code and consecutive? So if there's 7, how many would be if I reversed it?
7.
There would be 7. So how many total?
7.
So there would be
49.
14 total. No, take all these numbers, 0, 1, 2, 3, reverse it. 3, 2, 1, 0. Reverse this. So all the 7 that I have, I could reverse. I have 14 total. So that is 14 consecutive codes out of how many? 5,040. Okay, so I'd throw that in my calculator and reduce it. I get 1 over 360. And if you want to know the decimal, it's about 0.0028. So there is the probability as a reduced fraction or a decimal. So we had to think differently about these. Some of these are higher level probability. You can't just say, oh, it's a 1 out of 6 chance. Okay, I am going to move to this last one here. A DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are local retailer. What's the probability she'll play an ad or play both of the retailer's ads before her show? Do you see how she's picking 2 out of 8? Permutation or combination? It is, the order does matter because she has to pick, there's a first ad playing and a second ad playing, right?
Obviously.
If I was paying for these ads, I'd want to be the first one because people would probably change it once it gets started. So at least you get some of it in. So how many total ways can she play these ads? She has 8, she's picking 2. So how many ways can she play these ads? Put that in the calculator.
56. No.
So 8 permutation 2, I agree with your 56. Now, we want to find the probability that she plays both of the retailer's ads in a row. Okay, so think about this. There's 56 total. How many ways can she play these 2 ads specifically out of 8? 2 out of 56. There's ad 1 and ad 2, and then she could play it as ad 2 and 1. So there's 2 possible ways to play these in a row. Now, a lot of people probably want to say 1. There's only one way to pick these 2, but because the order mattered, retailer 1 commercial, and then the second one, or the second and the first. So 2 out of 56 reduces to 1 out of 28, which is a decimal of about 0.036.